All right. Well, if you're just jumping in, welcome to the Q&A portion of our webinar on using Six Sigma to solve problems. Excited to go even deeper than the presentations here with the Q&A with our two guest speakers, Susan and Nick. Thank you both so much for being here.
Thanks, Kirby.
Thanks, Kirby.
Appreciate you guys carving out time to, just answer some questions. Got a handful for you. The first one here, I actually see this one all the time and you guys see this one too, have a lot of people go through training, and oftentimes when they come through, whether it's yellow or green, they'll tell us like, hey, my boss has an idea of what we should be doing here, but that's not always what's actually acted on or implemented by the time they go through Six Sigma. So could you speak to that a little bit? How we use Six Sigma to prevent sometimes implementing your boss's solution and really use it to solve the problem? Nick, can you speak to this one first?
Yeah, I mean, I kind of alluded to it in the presentation where I thought I knew the solution and went down a path only to find myself right back at the beginning. Six Sigma offers that structure, and it has a very data-driven approach. It's really about rejecting ideas, not about rejecting ideas, and more about like validating that they are right.
Mm-hmm.
So you're driving to root cause. You take the emotion out, and you let the data speak.
I appreciate that. And it's probably especially important to let the data speak because it's that third-party perspective, if you will, when you're going to go talk to your boss about the fact that something else may be a better solution.
Data is pretty tough to debate. So
Yeah.
it is usually the foundation of all arguments.
Yeah, I appreciate that. Anything you'd add?
Basically, Nick just really hit it right on the head. It is the data. It's listen to the data. And beyond the data, talk to the people on the manufacturing line.
Mm.
Talk to the people who sit in front of it every single day. And let them guide you as to what kind of data you need to collect. That can be a big piece of it as well. Using that data to separate opinions from fact is absolutely critical to problem solving. And it can lead you away from your boss's favorite solution, but then you can show him the path, him or her.
The reality is your boss's favorite solution will be the one that overcomes the problem and lasts, right? So, I mean, that's what you really want. I think they'll always be open to that final solution.
Yeah.
Okay, so I have found myself overthinking stuff. And whenever I think I'm overthinking something, I actually start journaling. Whether I'm on my laptop and just like grinding my fingers to the bone, or kind of old school, pen, paper, and just clarity of thought, what's the real problem here? What's the data? And I'll just start journaling. I know that sometimes when you're using Six Sigma, going through that DMAIC process, sometimes you can kind of get in that same mode of analysis paralysis. So how have you either recommended that, engineers overcome that, and how have they used Six Sigma to overcome that? And or, what do you do to just bypass that altogether and say, hey, DMAIC this way and these experiences will help you avoid overthinking that analysis paralysis. Susan, I'll kick this one over to you first.
I guess what I would say is look at the data. And yeah, I understand what you mean about analysis paralysis. You've got so many different things. There's two ways to look at it. You've got so many different things you could measure. How do we even start paring it down to what you're going to measure? And then once you've measured it all, you choke. There's so much to do. How do you get started? Two huge tools to help you do that. One of them is the Pareto that Nick mentioned. I mean, that's a really, really good way to do it. Start looking at the biggest thing. Don't try to solve all of it at once. Just go, we're going to look at the Pareto. We're going to look at the biggest thing, and then do the next thing in order.
Yeah.
Another really good tool to use is optimization matrix, cause and effect matrix. So you can get your team together, have them sit down, and go through the different potential causes and weight the effect on the problem.
I like it. So real quick, for those that heard that word Pareto and they don't know what that means, because we used it a lot.
Yeah.
Quick definition.
Pareto principle, right? 80% of the problem is in 20% of the causes.
Yeah.
It's that bar chart that you see in meetings all the time where you have the biggest to the smallest effects. So you're capturing the thing that happens the most,
Yeah.
the cause from that happens the most, then the next one, then the next one. So it's that decreasing bar chart that you've seen in probably tons of meetings already.
Thank
But
you.
that is called a Pareto.
Thank you. So,
Good
Nick,
question.
if they haven't seen your presentation, they should actually go back and watch it. You spoke to it. But anything you would add to this that has helped you or you've seen help others avoid that analysis paralysis?
Yeah, so structurally, one of my favorite things about getting coached on a Six Sigma project is what I call forcing function reviews.
Hmm.
So DMA review, looking on the front end, and then an A to I review. And I say that because sometimes you get paralyzed in the decision making in the data until you have to make a decision. And the thing about iterative problem solving, if you're wrong, you just go to the next variable. So for me, it's about jumping off the cliff, having some trust and faith,
Yeah.
and having that meeting in some cases that forces you to make that decision.
I love that. You know, especially the part about experiments. It is an experiment. It's as scientific and data driven as you possibly can. But I always just think about like how much is the next experiment going to cost? And then let's run it. Run the play or run the experiment.
Yeah, the experiment you don't run is knowledge you don't gain. So you can sit there and chalk it up and be theoretical, but until you actually put it into practice, you aren't learning anything.
So my next question for you guys is there's kind of a stark contrast. I think about this one. I'm kind of exaggerating things on purpose here, but I think about packages. Like if I was at UPS and I've got a friend in industrial engineering, so he thinks a lot about those 18 wheelers, a lot about optimizing how many packages are in there and how they're stacked, how they're stored, and making sure there's no breakage or slackage, so it gets to the destination like 100% on time. But he knows like 100% on time is really expensive, right? Like that doesn't happen. We all know that doesn't happen. But there's a cost to improvement. But then I also think about the other side of it is, you know, many of us have had if you have kids, like you want to go home with the right kid, right?
Maybe not every day.
That's hilarious. But like, you know, the closer to 100%, the better. And so just a couple of scenarios to ask you guys this one. At what point in time does defect free not become worth the cost? And could you speak to that, Nick?
Yeah, I mean, Six Sigma is near perfection, but not at any cost. I think we talk about this a lot, and we use this acronym called GEMO, good enough, move on.
Hmm.
And I think at the end of the day, if we're meeting a customer requirement, like that's our stopping point. If we're not, we keep going. It's kind of back to that overproduction, overprocessing form of waste. So there comes a point where the squeeze is no longer worth the juice.
Yeah. Susan, what would you add to this? I mean, some great points around GEMO and just over engineering. I appreciate that.
Yeah, I think the best part about Nick's answer is to focus on the customer requirements.
Yeah.
And when it is good enough for the customer and it's meeting all of the customer requirements, do you need to keep it moving? Do you need to keep improving it? We have an example that was with Intercon, where we were building a new part, we were making a new part, we were trying to get plus or minus 0.005 on the tolerance. And they were saying, this is really hard. We can't really do this. And we talked to our design engineers and they said, oh, yeah, that's the default that was in the CAD program. We can go plus or minus 0.1. Unless you talk about it, unless you use that communication, you're stuck with that 0.005 tolerance when you didn't need it.
Yeah.
That 0.1 was the good enough.
I really respect that. Like, talk to your customer. Don't do things just because that's the way they've always been done.
Yep. Yep.
Appreciate it. Okay, so this next one is kind of AI driven, and just thinking about how there's AI process control, there's predictive maintenance, there's more and more sensors and more data on more and more machines. I'm in a couple manufacturers a week, and I'm seeing it all the time. And so some people do question, like, is Six Sigma outdated, especially in the age of AI? What would be your response to that?
My response to that is it's absolutely not outdated. It's going to help you. You've got a ton of data. You've got everything, from sea to shining sea that is being measured.
Yeah.
What do you pay attention to? You do not have time to pay attention to all of it. You don't have the resources to pay attention to all of it. Six Sigma is the process that helps you narrow that down, focus that down so that you can pay attention to what matters. And paying attention to the right things is what you need to do. You do not need to pay attention to everything. As a matter of fact, with inspection robotics,
Mm.
that's one of the major difficulties with implementing inspection robotics is the inspection robotics can actually be slower than the human eye because the human eye knows what to disregard. And you have to program the AI to disregard certain things.
Mm.
So pay attention to what matters. Know what matters is the first step toward doing that.
Great points. Appreciate that.
I mean, what I would say is AI actually is helping for folks that just aren't super confident about analyzing data. Uh, Maybe ashamed to say this, but sometimes when I get stuck, I throw it into it to Copilot or an AI bot, and
Mhm.
it is able to almost quickly or much quicker than I could identify where to focus.
Mm.
And sometimes I get writer's block and I don't know how to even start the brainstorm. And it seems like with data analysis, it's the same idea. You can feed it a nugget and it'll give you a couple of things to look at, which I think only complements the process.
I mean, AI just speeds it up. I appreciate that. I remember when I went to school, this is a few years ago now, and I had to do standard deviation calculations on stock portfolios to get rid of risk. That was painful. Painful. I mean, it took me like 20, 30 minutes, sometimes an hour to do a problem, like one. I'm like, there's 15 of these.
Yeah.
So I hear you. No shame in leveraging the tools that are available, right? In the best way possible. Okay, here's my last question for both of you before I let you go. So, a lot of bigger companies within the Manufacturers Alliance, and bigger as in, hey, we've got 3,000, 5,000, 7,000 people on the team. And then there's also companies that will say that, well, we're more custom. We are, engineer to order. We make one of these, roughly every 12 to 24 months. And they look at Six Sigma and they go, is that for the big companies that have standard product? I don't think that it's for us. So to what extent is Six Sigma really only for companies that have standard product?
I yeah, it's for all companies, and it kind of comes back to it's full circle, trying to find out where to focus. I've taught classes with people in companies who basically do that. They make 1 to 2 tremendously huge, like the data processing center or a huge test machine, and they make 1 to 2 of those a year. If they keep getting a failure, what the Six Sigma helps do is find out what component is causing that failure
Mm.
and then focus on that component. Use Six Sigma. Yeah, you're making 1 or 2 a year. I used to work in aircraft manufacturing. We don't make a ton of DC-10s or anything like that back in the day.
Great example.
So we would make 5 in a year because they're big and they take a lot of parts.
Yep.
But you still use Six Sigma to find out where the failures are coming from and how to fix them.
Well, I bet there was a lot to test, probably hundreds of components that could be causing it
Absolutely.
to really narrow it down.
Yep, it's finding that focus.
Yeah,
It really is.
I appreciate that. Nick, what would you add to this final question?
I'm, Six Sigma, we all have problems. And the beauty of the methodology is it provides structure. And I think it also provides a common language and a set of tools that we can all learn, train to, and use in that vernacular when we're solving problems. So even if you don't have the perfect situation, I think some of those elements become overly powerful when trying to solve problems.
Yeah, I think it's important. Everyone's rowing in the same direction. Everyone's speaking the same improvement language.
Mm.
That way, when you talk about a control chart or SPC, people aren't like, huh? Got to get them all on the same page. Well,
Thing the
Nick,
same way.
Susan, thank you both so much for joining me. I appreciate it.
Yeah, thanks,
Thanks,
Kirby.
Kirby.
If you liked these real world examples and the practical applications and you're looking for, even more in-depth training, then take a close look at our Six Sigma Professional Yellow Belt and Green Belt certification programs. It'll give you the training, experience, real world project work, even coaching to make sure that you can take what you're learning and apply it and show positive measurable benefits. Just click out the form that's right below the player. We'll send you some more information and then just answer any questions that you have. Thanks for watching, and we'll see you next month.